Alright, so now we're going to move on to the hyperbola. Hyperbola. However you want to pronounce it. I think that's how you spell it. Alright, let's go. So there are two different normal graphs, like we learned about over there. We have it's actually pretty similar. You have x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared equals 1. And this one is going to be focusing on if the graph is like this, and this is going to be focusing on if the graph is like this. Dominant on the x-axis, stuff going on over there. This is stuff going on the y-axis. So now the ones with h and k, all you're doing is the same idea. X minus h, look at that. We got the same thing again. Over a squared minus y minus k squared over b squared. And then the same thing for this one, which would be y minus k squared over a squared minus x minus h squared and over b squared. As you can see, k is always going with y and h is always going with x. Because h has to do with the x-axis, y has to do with, k has to do with the y-axis. Alright, so I'm going to put a graph down so that I don't run out of space, and then I will give you the steps. Here we go. One, two, three, 4, 5, 7, 1, 2, 5, 6. Alright, there we go. Alright, let's get our steps. So the first one, h and k for this one, just like all the other ones, is set the parabola. H and k is your center. So that's very important to get. H. Oh, I have to give you a practice problem. My bad, that might be important. Alright, our practice problem. This is going to be our practice problem. Our practice problem is going to be y minus 3 over 4, y minus 3 squared, my bad, over 4 minus x plus 1 squared over 9 equals 1. Alright, so our first step, this one is very important. Our first step is going to be, you need to get your h and your k. H equals -1 and k equals 3. Our next step is going to get our b and our y. Sorry, not our b and our y, our a and our b. Our a equals 2 and our b equals 3. And then the next one is you want to get our c. You're going to be using c squared equals a squared plus b squared. And that gets us, c is going to equal square root of 13, which is 3.6. c equals about square root of 13. As I said, this is the distance from your center to your foci. This doesn't change if you transform the graph. Doesn't really do much. Alright, so let's graph some points. We're going to graph -1, 3, which is our center. This is going to be right here. -1, 3. Then we would like to graph our a's and our b's. Just like for the ellipse, you're just going to be counting over. A is up and down because A is under the y, and B is side to side because it's under the x. So A is going to be going up 2 and down 2. 1, 2. And down 1, 2. And B is going to be over 3 and 3. 1, 2, 3. And it's going to be over 1, 2, 3. And what this is creating is your little box which we talked about, which I'm going to draw in another color. So we can use that little box that's kind of like an asymptote, which actually forms your asymptotes, which is really helpful when graphing. This is your box. And then what you can use from the box, just like we learned in hyperbolas, is you can draw your asymptotes through the corners of the box. So this is one asymptote. And another asymptote. And what this is that your graph cannot cross these lines. And it won't cross these lines if you do it correctly. And you follow what you just learned in 8.5. And then we also know that what we're going to do is you're going to just graph the circle, the hyperbola. You're going to be seeing this form of the graph. You're going to be doing that shape. So you're going to be taking this point and you're just going to making a curve. And look at that. Do it correctly. It'll get closer and closer to the asymptotes, but never actually touch them. And that is your basic hyperbola. We would also like to get your foci. Foci are going to be square root of 13 away from this point. So I'm going to count away square root of 13, which is about 3.6. So we go 1, 2, 3, about 0.6, which is about here. And 1, 2, 3, about 0.6, which is about here. And there you go. And as I said with the last one, you can either put your A and your B points, these 4 points, A, B, these are your foci. What you can either do is you can graphically just count over the amount, or take an individual point and you can transform that individual point by H and K. So I can take the individual points of 3, 0, which would be 3, 0, and I can minus 1 and plus 3. So normally it would be here, but what we're going to do is we're going to, and then you can do the transformations and you can get the point. Yeah. Checking my work real quick. Make sure that I did this correctly. Make sure I mess up on you guys. Yeah, that's how you do it. So you can just count over 3 from this, or you can just transform the point from being here, and then you would just do that. Oh, and that's why. This is negative 3. Negative 3 plus negative 1 is negative 4. I got it. 1, 2, 3, 4, up 3, 1, 2, 3, boom, it's the same point. All you're doing is you're transforming it by this, and that's how you can get the point. So you can either do it graphically, or you can do it with individual points. You see how I messed up a little bit with doing it like this, graphically. That's the way I do it. And that is how you graph the hyperbola. We have gotten our asymptotes, which are these black